Let us do one example on how to make a larger memory from a few pieces of memory IC that we have. Let's say we have 4 pieces of 1 kilowatt of 8-bit word, 1K by 8 each IC, and then we have 4 pieces of them. So in total, we actually have 4 kilowatt of 8-bit each. We draw the IC. Let us standardize the drawing for the connection of the IC for our class. It is like this. It will be in rectangles, of course, and then the connection that you need to put, you can put A only for address, or you can put ADDR, and then there will be data. Then you label each IC to be 1K. 1K means 1000 by 8-bit. You have to draw this better with your pen and paper. I have difficulty to make this drawing because I'm drawing using a stylus on a tablet, which is not so easy. And then you will need CS, chip select, and then read write. Write is active low. Then this is a 1K or 1000, but actually the exact amount is, the exact number of words is 1024, because this is to the power of 10. So the address line will be 10 bit to each of the IC. Because it is not one bit line, use a thicker pen to draw this one. So address line is a thick line. Then all these 10 bit will go to all the addresses. The branch, and then all these are 10 bit. But you see, this 10 bit is to address one of the word in each IC. But then the total is 4 kilo actually, which actually you need 2 more bits for addressing which one of the IC. To address one of the IC, you need a decoder. This one is 2 to 4. The output will go to chip select, like that. And then there will be 2 more address bits coming from the main address into the decoder. And you have to show that it is curving like that, because it is not branching but they split. What I mean here is that this is 2 bit, and the original line, this is actually 12 bit. Split of 2 goes to the decoder, and 10 goes to the address of the ICs. So this is actually the address line, the original address line. And then you need a thick line for data line also. Address and data, they are both bus. You need thick line. We're not going to show input data and output data. We just combine them into one line because that is the practice in the industry. Like that. And we will put arrow to show that this is input and output. And also to show that this is tri-state bus. So this is all 8-bit. This is the data line of D bit 7 to 0. It is an 8-bit bus. So what is left now? What is left is the read and write. It's only one line over here. This is read and write. Write is active low. Okay, so we have four pieces of 1 kilowatt of 8 bit per word. We can build a system of total 4 kilowatt of 8 bit for each word like this. Because we stack them together, we read word by word from each of the IC. So we end up 4 kilowatt. So this is the minimum drawing that you have to show. This will show that you understand how to organize the memory IC that you have.